The space probe Voyager 1, which has been traversing space for more than 40 years, has made an important announcement. During a trajectory beyond its initial mission, it has gone above and beyond all expectations, as it was originally expected to last only 5 years. Now, Voyager 1 has detected the presence of 300 unidentified objects traversing space. This discovery has completely changed our understanding, as these objects have been found to be plasmas from giant star explosions that occurred millions of years ago. Join us on this exploration of the universe to find out what these objects discovered by Voyager 1 are all about. Unlike previous years, when we were only able to analyze data throughout our solar system, Voyager's innovation has made it possible for us to now access information from beyond. In August 2012, Voyager 1 officially reached the boundaries of the solar system by crossing the heliopause. However, this milestone was not easy to achieve. As the probe moved farther and farther away from the Sun, the amount of sunlight available to power its instruments and systems considerably reduced. The spacecraft's power is generated mostly from 3 different radioisotope thermoelectric generators, which convert heat from the natural breakdown of plutonium-238 into electricity. As the heat output of the thermoelectric generators has decreased over time, the available power has diminished, affecting the operation of a number of onboard systems, including scientific instruments, data transmission, and communications. To conserve energy, instruments and systems that aren't necessary have been disabled or placed into a dormant state. As power continues to decline, it will be necessary to optimize or shut down Voyager 1's critical systems to prolong its operational life. It will not function in its current state for much longer, though it is still very valuable to us. However, the vast gap between Voyager 1 and Earth presents a significant challenge to maintaining effective communication. As the spacecraft ventures into interstellar space, Voyager 1's signal strength has weakened. It takes more than 21 hours for signals to travel from Voyager to Earth. The weak signal, combined with interference from background noise, makes it difficult to transmit and receive data. In addition, the temperature transition from the heliosphere to interstellar space exposes Voyager 1 to different thermal conditions. In the heliosphere, the spacecraft was closer to the Sun and experienced higher temperatures. When entering interstellar space, it now faces extremely low temperatures. The Voyager 1 probe is equipped with dust detectors specifically designed to measure deep interstellar dust densities. However, interaction with Voyager 1 has become more difficult due to limited resources. NASA's Global Antenna System is expected to continue receiving the mission signals, but this has resulted in less frequent communication opportunities than there used to be. Despite this, a fascinating discovery recently emerged in the midst of the data stream. Voyager 1 detected an intriguing anomaly: the presence of 300 unknown objects passing through interstellar space. This discovery has perplexed scientists around the world, as it challenges our understanding of the cosmos. Are these objects remnants of ancient celestial bodies drifting by, relics of distant star systems, or the result of previously unknown phenomena? Although the information transmitted by Voyager is usually easily deciphered, in this case, the data were encrypted, raising many questions but providing few answers. The oddest part is that, despite the peculiar nature of the data, Voyager 1 appeared to be functioning smoothly. Its communication link with Earth remained intact, and the signal remained strong, allowing valuable information to reach NASA without much trouble. Interestingly, none of the ship's protection systems were activated, indicating that there was no immediate threat. This rules out a possible attack. So, what may be causing the telemetry data to appear scrambled or inaccurate? Could it be the result of interference from cosmic events like radiation or high-energy particles? Or is it possible that we are dealing with a completely unknown phenomenon that defies our understanding of space? The only way to gain certainty was to conduct a meticulous analysis of a wide range of possibilities. The NASA research team carried out a thorough analysis of the systems, taking into account the impact of cosmic radiation on the electronics and the possibility of temperature fluctuations affecting their sensitive instruments. There was a possibility that something happened just before Voyager entered the heliosphere and that natural changes in its path created problems in data transmission. However, the location of Voyager 1 was not exactly clear, nor were the natural changes concentrated enough to cause such problems, so that did not appear to be the explanation. The team also looked into the complexities of Voyager 1's communication systems, exploring possible distortions caused by cosmic noise interference or even subtle changes in its trajectory. The search for answers led to a meticulous analysis of all these potential factors. The spacecraft systems were examined again, taking into account cosmic radiation's effect on electronic components and the possibility of temperature changes affecting sensitive instruments. While it might sound like a simple task of checking boxes, in reality, there was a lot of work to be done. Therefore, this investigation was not instantaneous, it dragged on for weeks. The team employed advanced data processing techniques, innovative algorithms, and ran simulations of various scenarios to identify the root cause of the unusual anomalies. At the time, this was the only way to discover what was causing the problems. And all that effort was not in vain. After months of receiving encrypted information from the spacecraft, scientists and engineers were finally able to restore clarity and reliability to the data coming from the far reaches of interstellar space. The problem was traced back to Voyager 1's Attitude Articulation and Control System, AACS. Specifically, a computer on board that was supposed to be idle. Surprisingly, it was discovered that the AACS had begun using the non-operational computer, which had not been active for years, leading to data corruption during transmission. While the rest of the spacecraft remained operational and continued to collect data, the engineers quickly sent a command instructing the AACS to shift to the correct computer to transmit telemetry data. Despite the low risk, the solution required a lot of patience due to the significant delay caused by the distance between Earth and Voyager 1. Radio signals take nearly 22 hours to travel back and forth. Thus, the troubleshooting process required careful coordination. However, there was still one problem to consider. Voyager 1 had been operating in a way no spacecraft ever had. It was no longer just a scientific instrument, it had become a fragile bridge between humanity and the unknown. Every adjustment, every command sent across billions of kilometers, was a delicate balance between risk and necessity. As the AACS shifted back to the correct system, engineers waited anxiously for confirmation. More than 20 hours later, the signal returned, stable, consistent, and, most importantly, clear. Telemetry data began to flow once again, and the anomalous encryption that had previously baffled scientists was gone. Voyager 1 was back online, and the mysterious data regarding the 300 objects could finally be analyzed without interference. The first detailed analyses revealed something astonishing. These objects were not just randomly floating through space, they seemed to be following a loose formation, their paths slightly curved as if influenced by a force unknown to current physics. Each object emitted a faint but measurable signature of ionized gas, consistent with supernova remnants, but the energy readings suggested an intensity far greater than previously recorded. What puzzled scientists most was that the readings didn't match any known category of space phenomena. They weren't asteroids, comets, or even traditional plasma clouds. Some of the signals even appeared to pulse at regular intervals, patterns that hinted at artificial origin, or at least some underlying logic. The scientific community was divided. Some argued for a natural explanation, perhaps these were ancient starborn materials caught in a gravitational anomaly, accelerated to high speeds through interactions we hadn't yet documented. Others, more speculative, wondered if these objects might be evidence of non-human intelligence, not spacecraft in the traditional sense, but data packets, probes, or remnants of something vastly more complex than we could yet grasp. NASA convened an emergency conference with international space agencies. Data from other telescopes and space observatories was pulled to cross-check Voyager's findings. The European Space Agency, JAXA, and even private aerospace firms joined the effort. For the first time in decades, Voyager 1 had not just inspired scientific curiosity, it had reignited global fascination. And through it all, Voyager 1 continued its silent flight, billions of kilometers from Earth, still listening, still watching. Every bite it sent back now carried the weight of hope, mystery, and possibility. Had we stumbled upon a natural cosmic relic, or the first signs that we are not alone in the universe? Only time, and Voyager, would tell. Erected decades earlier, it had been performing excellently up to that point. Consequently, finding a solution to the current problems would be a major challenge. It was necessary for them to review several manuals from the 1970s, and that is exactly what they did. After careful examination, they found a simple solution to the issue. By re-establishing the system accountable for the transmission of data, they were able to solve the issue without affecting any other part of the ship. The experience and dedication of the engineering team was a very important contribution to the clarification of Voyager 1's communications. Their efforts underscored the significance of combining previous knowledge with current technology to deal with the problems of space exploration. Engineers suspect the deviation, the use of the non-operational computer on Voyager 1, was triggered by a faulty command received from a different system on board. This hypothesis suggests an underlying problem in the intricate spacecraft computer network. Mission managers remain cautiously optimistic and emphasize that this incident is not dangerous to the long-term well-being of Voyager 1. The spacecraft corrected the error and continued with its mission right after the correct computers came back online. Thank you very much for watching the video. Remember to like and subscribe, and I'll see you in the next one, as Voyager 1 continues its journey through the vast, unexplored interstellar lands. The implications of its recent findings are profound. The detection of 300 unknown objects, likely plasmas from ancient stellar explosions, has sparked a wave of scientific inquiry, raising questions about what else might be drifting in the quiet darkness beyond our solar system. These plasmas, remnants of supernovae, offer a unique glimpse into the cosmic past. Scientists believe that by studying their composition and behavior, we can learn more about how elements are distributed across the galaxy, how stars die, and how the raw materials for new star systems are formed. It's a reminder that Voyager 1 is more than just a historical remnant, it is a tool that continues to reshape our comprehension of the universe. Still in use despite its age, Voyager 1 continues to be one of the most advanced pieces of engineering humanity has ever launched. Its instruments, despite being outdated by today's standards, continue to function, thanks to careful energy management and the unwavering commitment of mission control. Each new transmission it sends is a small miracle, a whisper from the edge of the known, traveling billions of kilometers to get to us. What makes this mission even more extraordinary is the enduring legacy it carries. Aboard Voyager 1 is the well-known time capsule containing the Golden Record, sounds and images from Earth intended to communicate the story of our world to any extraterrestrial life that might one day find it. It includes greetings in 55 languages, music ranging from Beethoven to Chuck Berry, and sounds of nature, from a baby crying to the roar of the ocean. This symbolic gesture, dreamed up by a team led by Carl Sagan, reminds us that Voyager 1 is more than just a machine. It's a messenger, a testament to curiosity, imagination, and our desire to connect with the cosmos, even merely to state that we were looking ahead. Mission scientists are preparing for the eventual end of Voyager 1's journey. Its power supply, slowly fading, is expected to last only a few more years. By 2030, most of its instruments will be turned off, with the final signal possibly ceasing shortly after. Yet even when it goes silent, Voyager 1 will continue to drift, silently and steadily, into the unknown. It will become a ghost ship of humanity, carrying our message across the stars, possibly for millions of years, long after the entire planet has changed beyond recognition, and long after the lights of our civilization may dim. In the grand scope of space and time, Voyager 1 is but a speck of sand on a vast coastline. But it carries with it the hopes, dreams, and questions of a species as a whole. So, what lies ahead? Could future space missions go even farther with more advanced technology that follows Voyager's lead? Will we one day send crewed missions beyond the solar system? Or maybe, just maybe, something or someone will eventually find our little golden disk, drifting through the dark. For the time being, Voyager 1 continues, extending the boundaries of what is possible. And as we wait, we listen. We wonder. As Voyager 1 drifts farther from home, its journey becomes a testament to human resilience and curiosity. Even as its instruments slowly shut down, its presence in the cosmos serves as a silent reminder of our quest for knowledge. The spacecraft, now over 24 billion kilometers from Earth, continues sending signals, each one fainter than the last, yet still reaching us across the vast expanse of space. Scientists anticipate that within a decade, Voyager 1's power supply will no longer sustain even its most essential functions. When that moment arrives, its final transmission will mark the end of an era, yet not the end of its story. It will continue moving forward, undisturbed by time, carrying with it the legacy of a species that dared to explore. Perhaps, millions of years from now, an intelligent civilization will stumble upon this lonely traveler. They will find the golden record, a snapshot of who we were, our voices, our music, our dreams. What will they think of us? Will they understand our message? Or will Voyager remain an enigma, a relic of a civilization long gone, drifting endlessly in the cosmic abyss? For now, we can only watch, listen, and wonder. The spacecraft may be silent one day, but its mission will never truly end. Voyager 1 is more than just a machine, it is a symbol of human ambition, a bridge between what we know and what we have yet to discover. As it moves through the interstellar void, it reminds us of something profound, that no matter how small we are in the vastness of space, our reach, our curiosity, and our legacy can extend beyond the stars. And so, Voyager 1 continues, onward, into eternity.